Hello class, welcome to our lesson today dealing with section 14.5. Today we're going to use the Pythagorean theorem in a few different ways. So let's go ahead and get started with our review question today, and then we'll get into the Pythagorean theorem questions. These two questions are just two-step equations, but require you to do a little bit extra work. Okay, so you need to distribute the 5 into the x minus 2 distributing, or you could have divided by 5 on both sides. The reason I chose not to divide by 5 is because it doesn't divide nicely with negative 21. But you could do that and get to the same answer. That'll give me 5x minus 10 is negative 21. To get rid of minus 10, I'm going to do plus 10 on both sides. Realize negative 21 and 10 are on opposite sides, so it's really a subtraction problem. It's 11 and negative because the larger number is negative. And then divide by 5 and you get negative 2.2. I've noticed that students, when you have questions like this, especially on a test, forget this negative sign in the final answer, so make sure you're paying attention to that in the future. In the next one, you just need to combine like terms. So 4x plus 6x is 10x. 10x minus 8 equals 14. Add 8 to both sides, so 10x equals 22. Divide by 10, and x is 2.2. I think that was a little bit more straightforward. The only thing is make sure you watch your subtraction symbols. Remember, the subtraction symbol goes with whatever piece is next to it, to the right, because it's basically keep, change. So any minus sign should go to the coefficient or the constant on the right side, not the left. Okay, today we're going to talk about what's known as a converse. A converse takes whatever is told as a hypothesis and a conclusion and switches them. So in the base case, if P then Q is a statement, then the converse is if Q then P. So let's go through a few converse ideas and then we'll go through it with the Pythagorean theorem. Write the converse and then determine if the converse is true. If it's true, justify the reasoning. If it's false, provide a counterexample. So this says if A equals B, then B equals A. The converse would be if B equals A, then A equals B. Notice I just switched the statements around. That's going to be true, and the reasoning is, well, if 5 equals 5 and then 5 equals 5, if you switch the order of that, that really doesn't matter. The next one says if I was born in Indiana, I was born in the United States, which is true. The converse of that would switch those two statements. If I was born in the U.S., then I was born in Indiana. And that's not true because there's 49 other states you could have been born in the U.S. and territories and things like that. So when you're looking at the converse of this one, it's false. So just because a statement is true from its original setup doesn't mean its converse is going to be true. The next one, if A equals B, then A squared equals B squared. So the idea here would be, don't forget about negatives. If 5 equals 5, then 5 squared equals 5 squared, which is true because 25 equals 25. But if two numbers squared are the same, it doesn't mean that their original values were the same. Because, for example, I could say 25 equals 25, but A could have been 5 and B could have been negative 5 because 5 squared is 25 and negative 5 squared is 25. So that would be a counterexample to this one. If two triangles are similar, then they have the same angle measurements. Then the converse would be if the angle or the triangles have the same angle measurements, then the triangles are similar, and that would be true. Those correlate directly to one another. Okay, the Pythagorean theorem. Remember, the Pythagorean theorem said in any right triangle, so if it's a right triangle, then the sums of the squares of the lengths of the legs or the sides add up to be the square of the hypotenuse. So that's a squared plus b squared equals c squared. So if it's a right triangle, then a squared plus b squared equals c squared. The converse of that would be if a squared plus b squared equals c squared, then it's a right triangle, which is a true statement. So what this allows us to do is to take side lengths of any triangle, and without doing anything but the Pythagorean theorem converse, we can figure out if it's a right triangle. The key is you have to know which one is C. So remember, C is the hypotenuse, which is the largest side. So in this case, A and B are 3 and 4. So 3 squared plus 4 squared. I'm going to check to see if it equals 5 squared. Now notice here I put a question mark because I want to make sure that it's true or not. 3 squared is 9, 4 squared is 16, 5 squared is 25. Does 25 equal 25 when I add the left side together? And the answer is yes. If the answer is yes, then this is a right triangle. Your work should look similar to this question as you're going through these. Initial setup, plug in, add together on the left side, and see if the answer is yes or no. Next one, 12, 18, and 24 feet. Remember, 24 feet has to be the hypotenuse because it's the longest side. 12 squared is 144, 18 squared is 324, equals 576. Well, just that alone, I know it's false because 4 plus 4, this end spot's an 8 and it's supposed to be a 6. It ends up being 468 on the left side, so that would be an answer of no. The next one, the hypotenuse, make sure you know which one the hypotenuse has to be. It has to be the 41. So that would be 9 squared plus 40 squared. Now remember, those two are interchangeable. You could switch the order of those and it would still work just fine. So 9 squared plus 40 squared equals 41 squared, which gives me 81 plus 1600. Add those together, I get 1681, equals 41 squared, which is 1681. And so the answer is yes. If I draw a triangle with these three side lengths, it should be a right triangle, and I didn't even have to have a protractor in order to find that. The other application of the Pythagorean theorem we want to look at is what's known as distance formula. So this says find the distance between the points 2, 3, and 8, 6. So here's the point 2, 3, and here's the point 8, 6. Now what you notice here is I just make a right triangle myself because I know it's on a coordinate plane. I can think of the grid piece. This corner has to be a right angle. So then really what I'm doing is the Pythagorean theorem. You'll notice here at the bottom I got the number 6. Well, I got that by saying I start at 2 and I count over to 8. Or I could find the range or the distance between them, and 8 minus 2 would be 6. I do the same thing with the vertical. 6 minus 3 is 3. So then it's 3 squared plus 6 squared equals c squared. 3 squared is 9, 6 squared is 36. Add those together, I get 45. And now remember, this is from our previous lesson. To solve for c, I have to square root it, and it's the square root of 45. I left it in what's known as the radical form or with the square root. You may have to write things as a decimal, which is just plug that into your calculator to find that answer. But the distance formula is really just a Pythagorean theorem question. The next slide has the definition and formula used for distance as you go through the rest of your classes. It looks a little confusing, but it's really not that bad. This says the distance, d, which we use c on the last one, but same idea, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now x2 and x1, y2, y1, those are just ordered pairs. So what you'll notice here is this one's just labeled x2, y2. So this is like the second x value and the second y value minus the first x value and first y value. But what's important is in this blue and red area is really that's the difference between the x's, and then the red is the difference between the y's, which is really what we did here. We took 6 and found that by 8 minus 2, which is the difference in the x's, x2 minus x1. And here 6 minus 3 was y2 minus y1. From there, we just did Pythagorean theorem. They're adding in the square root and squaring all in one big kind of formula. You can use either version right now, but realize that this distance formula is something that you're going to see more often. Also realize that the squaring and square rooting can't cancel themselves because there's an addition in the middle. So we had to add these two pieces together, then take the square root in order to find the answer. So this one says find the distance between 1, 5 and -4, -2. There's two ways that I could do this. One way is I graph the 2 points and then find the distance in the x. So from this spot here, 1, 2, 3, 4, 5, which is this, or 1 minus -4 or -4 minus 1, that distance will be 5. And then this distance here will be 7 if I do the same thing with 5 and -2. From there, I could do Pythagorean theorem, 5 squared plus 7 squared. I put d squared because we're used to calling it the distance for the distance formula. If you use a c like this scenario, it'll be the same answer. The fact that the variable is different really is irrelevant to these scenarios. If we're going to use the distance formula, we could do the exact same thing just in a different setup. So I'm going to call this x1 and y1, and then this -4 and -2 is x2, y2. So x2 minus x1, which would be -4 minus 1 squared, plus -2 minus 5 squared. -4 minus 1 is -4 plus -1, which is two negatives added together, -5 squared. And then -2 minus 5 is -7 for a similar reason. -5 squared is 25 because a negative times a negative is still positive. And then 49 for the other one. Notice here in my formula I had negatives involved, but then they go away once I square them. That would be a similar idea here if I went backwards. It's -5 if I went from right to left, and -7 if I went up to down. But because the Pythagorean theorem is about distances, okay, in these scenarios, it doesn't really matter what was negative or not. 25 plus 49 is 74, and I square root it. If I wanted to find that answer, it should be bigger than 8, less than 9, because the square root of 64 is 8, the square root of 81 is 9, and it's in between. Your homework today is section 14.5, numbers 3 through 15, number 21 and 25. Make sure you show your setups on all of these questions. Definitely use a calculator on 10 and 25. I don't think you'll really need a calculator. In fact, I would encourage you trying it without, because you should be able to find the numbers that you need fairly quickly. Plus, it gives us a little bit of work on dealing with multiplication of some bigger numbers and adding a little bit. So make sure you try the rest of those without your calculator. Please make sure you show the setups and show your work on all of these questions. They should look similar to these different scenarios with trying to figure out yes or no, and then the distance formula questions using the Pythagorean theorem ideas and the distance formula. Have a good day, everyone.